A pharmaceutical company is researching a new treatment for a specific disease by adding material M to a petri dish filled with diseased cells. After the material is added, readings are taken at intervals to monitor the number of diseased cells, denoted as C, in relation to the weight of the material M. This sounds very exciting. The head of the research team has determined that the rate at which C is decreasing with respect to M is directly proportional to the natural logarithm of the square of M. Which of the following equations could describe this relationship? All right, well, we've got first off, rate. Weight with respect to M, rate of C with respect to M is this. They care about when C is decreasing, so it's going to be negative. Since it's directly proportional, keep in mind directly proportional is usually in this form. You learned that back in Algebra 1. So we're going to have some arbitrary k, and it's to the natural logarithm of the square of m. So negative k ln of m squared. Which, if you wanted to, you could take it one step further and rip that 2 out, but it looks like they don't need you to. It looks like right off the bat we have our guy, and it's going to be C. Kind of a weird problem. Lots more reading than doing, but we did it. Given that f of t represents the position of a car as a function of t, where t is the time in minutes since the car started moving, which of the following represents the velocity of the car? Well, if you're given a position function, the velocity function is just going to be the derivative of the position function, and the answer is C. So thank you for watching. I hope you guys had a really good time. Don't forget to like and subscribe. If S of t is a baby's shoe size at time t, which of the following differential equations describes linear growth in the size of the baby's shoes? So you're given a bunch of ds dt's here. Remember, ds dt stands for slope. So ds dt is slope. In order for the actual thing, the actual equation to be linear, the slope has to be constant, a regular number, like 5 or 12 or 2. So C is the answer because the rate of change needs to be a constant in order for it to be linear. The maximum safe load for a horizontal beam of fixed width changes depending on the length L of the beam. So we have ds dl happening here. The load S decreases with respect to L and is proportional to the product of its width and the square of its height, and inversely proportional to its length L. Which of the following differential equations model this relationship? So we got, it looks like 3 things that we're kind of looking at here. First things first, the load decreases with respect to L. Okay, so that's going to give us a negative going on here. Okay. Now, proportional relationships are given to you as the form y equals kx, right? This is telling me proportional to the product of its width and the square of its height, all right? So we're going to have a k, we're going to have a w, and its height squared. Now, if it's inversely proportional, you're going to divide that guy, so it's going to be inversely proportional to its length, L. So when we have all of this stuff together, looks like C is going to be my answer. So kind of a grody looking problem, not so much fun, but yeah, that's how you do it. Which of the following functions is a solution to the differential equation y double prime minus 4y equals 0? Well, in order to do this, we have to find out what y double prime of these guys are and test them out. So let's start out with A, where y equals e to the 2x. Y single prime is going to involve chain rule. Okay, keep the derivative of the outside, which is e, or take the derivative of the outside rather, which is e, keep the inside, which is 2x, but multiply everything by the derivative of the inside, which is 2. Okay, now let's do it again. Y double prime, keep the outside, or take the derivative rather of the outside, which is e, keep the inside, which is 2x, multiply everything to the derivative of the inside. So 2 times 2 is 4. So let's test out to see if A works for you. Y prime is now 4e to the 2x minus 4 times the y that we were given is e to the 2x. 4e to the 2x minus 4e to the 2x does give us 0. It checks out, so A is going to be my answer. Now, if it wasn't, we would just try all of these and see what happens, but since A worked, we're sticking with A. Of the following, which are solutions to the differential equation y double prime minus 5y prime plus 4y equals 0? Oh, all right, so let's do this guy in red. We have y, right? So y equals 5 cos 2x. Now let's find y prime. Okay, the derivative of 5 cos 2x is going to involve chain rule, so 5 is just there. Take the derivative of the outside, which is cosine x, so negative sine. Keep the inside, but then multiply everything by the derivative of the inside. So you become negative 10 sine 2x. Y double prime is going to be negative 10. Take the derivative of sine, which is cosine. Keep the inside, but then multiply everything by the derivative of the inside. So you become negative 20 cosine 2x, and that should do it. So let's test it out. Okay, y double prime is negative 10. Nope. Negative 20 cosine 2x minus 5 times y prime, which is negative 10 sine 2x, plus 4 times y, which is 5 cos 2x. And I'm supposed to get 0 when I do all that. Now, quick math will tell you that the negative 20 cos 2x and the 4 times 5 is going to be positive 20 cos 2x. Those will go away, but we're going to be left with a 50 sine 2x. That doesn't disappear, which means it's not going to be 0. So 1 is not going to be an option. So get rid of you and get rid of you. Okay, let's try out option number 2 and see if that works. So option number 2 gives us a y of 2e to the x. This is easy. Y prime is also 2e to the x, and y double prime is also 2e to the x. So when we plug it into this guy, we have y double prime, which is 2e to the x, minus 5y single prime, so times 2e to the x, plus 4 times regular y, which is 2e to the x. I'm supposed to get 0. So 2e to the x minus 10e to the x plus 8e to the x is going to end up being 0. So 2 actually does work. Hooray! So that is a possible option, but we're not done yet because I could still get 3. So let's test out. It's not going to be 3 only, we know that, so if we want to get rid of you for funsies, let's get rid of you. Let's try that out. So some arbitrary constant c, so y is going to be some c e to the 4x. Y prime is going to have me keep e there, drop down the 4 to that c to the 4x. Y double prime is chain rule again, so drop down the 4, 16c e to the 4x. All right, so let's try this out one more time. Y double prime is 16c e to the 4x. Minus 5 times y single prime is going to be 4c e to the 4x plus 4 times regular y, so 4 times c e to the 4x, and my job is to get 0. 16c e to the 4x minus 20c e to the 4x plus 4c e to the 4x. 16 minus 20 is negative 4 plus 4 is 0 equals 0. So you work, which means you also work, which means the answer is going to be 2 and 3. Dos y tres. Very good. Given y equals k sine negative x plus 2 cos 3x, the differential equation 2y double prime because plus 18y equals 32 times the sine of inverse x. Find a value of k that satisfies the equation. So what I need to do is I need to find out what y double prime of, or what y double prime is. So y single prime is going to be k, you become cosine, take the derivative of the inside, throw it out front, make it negative, keep the inside the way it is. Great. Plus 2, the derivative of cosine is negative sine, so negative sine. Keep 3x there, but then multiply everything by 3, so that negative 2 becomes negative 6. So I will, oh no, I will write that all there. So we've got what? Minus 6 sine 3x. All right, let's do it again. Y double prime. We have negative k sine, because the derivative of cosine is negative sine. And then we're going to multiply everything by the negative. So a third negative is going to come out front. So we only need one negative lingering around. So let's get rid of one negative. There you have it. Okay. Minus 6. The derivative of sine is cosine, so I shouldn't have written out sine. The derivative of sine is cosine. Keep the inside, multiply everything by the derivative of the inside, which is 3, so that 6 becomes 18. All right, so here we have it. We finally have our y double prime, and we have our original y prime, and we need to find out the value of k that satisfies this equation right here. All right, so 2 times that negative k sine negative x minus 18 cos 3x, close that, plus 18y, which is going to be k sine negative x plus 2 cos 3x has to equal 32 sine negative x. All right, so let's distribute. Let's do a little bit of distributive property. Negative 2k sine negative x minus 36 cosine 3x plus 18k sine negative x plus 36 cos 3x equals 32 sine negative x. U combine with U to make 16k sine negative x. U and U cancel each other out, and on the right side I have 32 sine negative x. In order to get k all by itself, let's divide both sides by 16 and sine negative x. Divide both sides by 16 and sine negative x. You cancel, you cancel, you cancel. And k is going to equal whatever 32 over 16 is, which is 2. Not a fun problem, not a fun problem at all. Use the differential equation to create a slope field. So a problem like this could take a very, very, very long time and show a lot of work, so I'm going to try to do this somewhat quickly. But the way you handle this is you have, wow, is this 25 points? So this is going to take a few minutes. You have 25 points here, and you choose one of the points. And let me show you that algebraically, and maybe from there we can do a little bit of mental math. So let me pick this point right here. Okay, dy dx means the derivative. The derivative means slope. That point right there is the point negative 2, positive 2. Okay, negative 2 is an x value, positive 2 is a y value. So to find the slope at that point, we replace x with negative 2 and y with positive 2. and that gives us negative 4. And the slope of negative 4 is going to look like a steep negative line. So what a slope field looks like is we just take turns plugging in points into the differential equation to see what we get. Okay, so let's try it again with one more point. Let's try this point right here, which is going to be negative 2, positive 1. Okay, so negative 2 is my x, positive 1 is my y. So dy dx, the slope, is going to be replacing negative 2 with x, or vice versa, and replacing y with 1, and that gives us negative 2, which is a less steep negative line. And then we just keep doing this. Now here's the nice thing. This is where life is going to get pretty easy. Okay, a little bit. Everything along the x-axis has a y value of 0. And if I were to multiply anything by 0, I get 0. So all of these are going to be a flat line that looks like this. Similarly, everything along the y-axis has an x value of 0. So you're also going to get these flat lines like so. So now instead of having to worry about 25 of them, I only have to worry about 16 of them. Isn't that great? Let's keep this thing going. Basically, the rest of these, and let me get a different marker. The rest of these are just going to be me taking the points and multiplying them together. Okay, negative 2 times negative 1 is going to be a positive 2, so a pretty steep slope, positive direction. Negative 2 times negative 2 is positive 4, so a steeper slope that's positive looks like this. Okay, let's come up here. Negative 1 times 2 is going to be the same as that guy, negative 2, so a pretty steep slope. Negative 1 times 1 is negative 1, so as diagonal can be. Negative 1 times negative 1 is positive 1, so as diagonal can be. Negative 1 times negative 2 is going to be positive 2, so something along that line. Okay, let's come up here. 1 times 2 is going to be 2. Pretty steep positive slope. 1 times 1 is going to be 1, so as diagonal can be. 2 times 2 is 4, so steeper positive slope. 2 times 1 is 2, so pretty steep positive slope. Negative 1 times 1 down here is going to be as diagonal can be. 1 times negative 2 is going to be a pretty steep slope. Negative 1 times 2 right here is going to be the same that we just drew out. And negative 2 times negative 2, positive 2 rather, is going to be a steep negative slope. So definitely not the prettiest picture that I've ever drawn, but you can kind of see how things spread out a little bit and kind of things, I don't know, flay out, if that even is a word. But yeah, that's how you draw a slope field. Never a fun thing to do, but not too difficult. Below is a slope field for which of the following differential equations. So we have this slope field going on right here. And whenever you're trying to match up a slope field with its differential equation, you want to look for either zeros first or zeros first. That's probably the best thing to do. I don't know why I said or there. Let's look for zeros first. So it seems to me that everything perfectly diagonally is going to give me my zero slope, which means like a negative 3 and a positive 3 will somehow turn into a 0, or a negative 2 and a positive 2 will somehow turn into a 0. So which of these would allow me to do that? Like if I were to test out negative 2 and positive 2, which one of these would allow me to do that? Well, A won't, because if I were to plug in negative 2, I get negative 1, so that won't work. If I were to plug in negative 2, I'd get 4, so that won't work. Negative 2 and positive 2 would give me 0, so that's so far so good. How about if I were to plug in, let me see, negative 2, positive 2, that would be 1, so that won't work. ln of y, so since I'm using positive 2, ln of 2 is a regular old number, so that one won't work either. So C is the only one that seems to make sense. And, you know, if you had more than one option here after we tried out those numbers, then you would choose other numbers to plug in and see if they work. But this guy seems to do the job pretty nicely, so I'm sticking with C. The figure below shows the slope field for the differential equation dy dx equals x over 2y. Calculate the derivative at the point 3, 2 and verify that the results agree with the figure. All right, so this is my point. We'll label u x, we'll label u y. That's my differential equation dy dx equals x over 2y. Let's replace that x with 3. Let's replace that y with 2, so we get 3 over 2 times 2, which is 3/4. So we're looking at a positive slope, a little bit more shallow than 1. So let's label, or let's find 3, 2. So here's 3, here's 2, and that guy seems to match up pretty nicely with that guy. So I'd say, yeah, sure, it works. Thanks for watching. Shown above is a slope field for which of the following differential equations. So we have this slope field here, we have a bunch of options here, and let's see what we can notice. What you should always try to do first is find out where your slope is 0. When y is 0, we have a slope of 0. When x is 1, we have a slope of 0 too. Okay, so let's do a little bit of mental math and see if we can eliminate anything. Okay, so at the point 1, 0, we should get 0. So you're an x, you're a y. Let's eliminate some stuff right there. Okay, so 1 times 0 is 0. 0 minus 1, I'm sorry, 0 minus 0 is 0, so A seems to check out so far. Okay, again, 1 times 0 is 0, plus 0. You seem to check out so far, so far we're not having good luck here. Until now, we have 1 minus 0 squared is going to be 1, so C is not an option because we don't get 0. We get 1 minus 0 inside the parentheses, which is 0, and 0 times anything is going to be 0, so you seem to check out, so D is still an option. And then E, we get 1 minus 1, which is 0, so yeah, you're still an option. So E, D, A, and B are still options, C is not. So now that we kind of eliminated one of them, let's see if we can eliminate any more. So we pick a random point, let's say U, because that looks like that gives us a slope of 1 right around there. That looks like a perfect 1 slope. That exists at the point 0, negative 1. So if I label u x and label u y, I'm expecting to get positive 1 when I do some math. Okay, so let's do some math. I always like to try to use zeros and stuff like that because it helps things go away when I run into problems like these. So if I'm going to plug it into here, I'm going to get 0 times negative 1, which is 0, minus sign. Y is negative 1, so a double negative 1 appears to be 1, so you check out so far. Okay. Similarly, 0 times negative 1 is 0, plus y is negative 1, gives us negative 1. I want positive 1. B is not going to work. If x is 0, I get 0 minus 1, which is negative 1, times y squared, which is negative 1 times positive 1, because negative 1 squared is going to be positive 1. You end up being negative 1, so D is not an option. And last but not least, if I plug in 0 here, I get 0 minus 1 cubed, which is negative 1 cubed, which is also negative 1. So E is not going to work. So A's got to be my guy. The frustrating thing about problems like these is you can test out other points and completely waste your time. Like you can look at some of these and like maybe plug in the point, I don't know, you can plug in the point 2, 1, because that looks like a 1 slope, and then maybe not get a result that you want. Fortunately, I picked that guy right there, and it seemed to give me the result that I wanted, and that result happens to be A, baby. The figure to the right shows the slope for the differential equation dy dx equals 1 minus xy. All right. Sketch the graph of a particular solution that contains 0, 2. Label this point as point A. So I hate these. I'm terrible at these, but let's try our best. 0, 2 lives right there. Okay, what you want to do is you want to use the slopes. Oh, by the way, we'll call you A. You want to use the slopes to kind of try to figure out the pattern as to what's going on. Okay, right here, I happen to be in between these two lines right here. So what I'm going to do is I'm going to try to trace along this slope and get that, and get that. Again, we're not looking for perfection here because it looks like I had an anxiety attack while drawing that out. But that's the idea. You just kind of draw it out and sketch it to the best of your ability. Sketch the graph of a particular solution that contains -1, -2, which is going to be this guy right here. Okay, now this one doesn't necessarily fall on the thing. We're labeling it B, but we're still going to follow like the pattern. So this seems to kind of do a similar thing here, right? This seems to kind of then like go up here a little bit and maybe level out there. Okay, so drawing these things aren't fun. It's not a science, it's more of an art, and it's more of you, like I said, sketching things out and just doing the best that you can. And unfortunately, that's the best that I can. So please like and subscribe and leave a comment. The slope field for a certain differential equation is shown to the right. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 0? Well, y of 0 equals 0 is going to be the point 0, 0. So let's label it x and y. Let's go to 0, 0, and our slope is 0. So what we need to do is I need to basically look at all of these and see which of these is going to be matching up if I plug in 0, 0. So I can probably eliminate 1 or 2 or maybe even 3 of them if I plug in 0, 0. If I plug in 0, 0 here, I do get 0 over -4, so you will check out so far, so A is an option. If I plug in 0 for tangent, tangent of 0 is 0, and 2 plus x is 2, so you will check out. If I were to plug in 0 here, I would get e to the 2, so c is not an option because I will not get 0. And if I plug in 0 here, I get 0 over 2, which is 0, so you seem to check out. Now this is what I need to do. I need to kind of look at the picture that I have and try to figure out what kind of pattern that I have going on. Okay, it looks to me that if I were to put a point at -2, I have myself what appears to be a vertical asymptote at -2. Okay, which means you would do that for me, you would do that for me, you would do that for me. It also appears that as if I were to pick a point like here, if I were to pick a point and notice the behaviors of something, it looks like this guy kind of slopes down and shoots back up like this. Okay, shoots back up like that, which indicates here some type of horizontal or slant rather asymptote. Now only one of these is going to give us a slant asymptote, and a slant asymptote exists when the degree in the numerator is 1 more than the degree in the denominator, and that happens to be d. Okay, you would level out at 0. You would have a horizontal asymptote at 0 because the degree in the denominator is higher than the numerator, and that's not the behavior that we're seeing here. We're showing behavior where it seems to, our graph seems to be increasing along 0, not leveling out. And if you're wondering, well, why not tangent? Why not tangent? Because this doesn't seem to be exploding again. Okay, tangent would do that. Tangent would have like another explosion and hit zeros again after a specific pi value, and that's not happening here. So B is not going to be it. The slope field for a certain differential equation is shown. Which of the following could be a solution to the differential equation with the initial condition of y of 0 equals 1? Well, y of 0 equals 1 means we have the point xy, and that point is 0, 1. At 0, 1, it looks like what's created here is a circle, like that. And it appears to be a circle with a radius of 1 at a center at 0, 0. And the equation of a circle with a radius of 1 at 0, 0 being the center is going to be this guy right here. Okay, you would be a circle but not at 0, 0, and that's a radius of 2. And you would be just linear equations, or not linear equations, some type of weird looking sideways parabola, but that's not what we have. So the answer for this one is going to be D, because that is exactly the picture that we get when we sketch it out. All All right, so for this guy, we need to find the general solution to the differential equation dy dx equals 3x squared over y. This is what we need to do. We need to crisscross applesauce, like so, and say that we have 3x squared dx, leave a little bit of space, y dy. Now let's integrate both sides with respect to their specific variable. So if I integrate 3x squared dx, I get x cubed, how nice, plus some arbitrary c. That's going to equal the integral of y dy, which is going to be 1/2 y squared plus some arbitrary c. Now, these c's don't really matter, so choose one, get rid of the other, so adios. What I need to do now is I need to solve for c, which I shouldn't have done that because I should have just kept that c over there. Stupid me, doesn't really matter. Minus c gives us x cubed minus c equals 1/2 y squared. Okay, to solve for y, we need to multiply both sides by 2. Okay, so multiplying both sides by 2, and let me kill two birds with one stone here. Okay, the right side just becomes y squared, easy peasy. If I multiply 2 to x cubed, 2x cubed, we know that. 2 times negative c changes nothing. In fact, I'm going to keep it as positive c because it's just some arbitrary constant anyway. It doesn't really matter what it ends up being. Now I need to square root everything, and when I square root both sides, I can't forget the positive or the negative, and so let's just flip this over and have y equals positive or negative square root of 2x cubed plus c. And that's going to be my guy. Fun stuff. Find the general solution of the differential equation dy dx equals y plus 5 in parentheses times x plus 2 in parentheses. So this is what we need to do. We need to separate the variables with their respective dy dx. Okay, so if I were to multiply both sides by dx, and while I'm at it, divide both sides by y plus 5, this is going to look sloppy, but bear with me. Okay, that cancels out, that cancels out. And what I'm left with on the left side is 1 over y plus 5 dy is equal to x plus 2 dx. Now, in order to make those dy's and dx's go away, we have to integrate both sides with their respective y and x values. Okay, so the left side is going to require u substitution. So let's let u equal y plus 5. Du dx, or du dy, I guess in this case, would equal 1. How nice. And so multiplying both sides is going to give us du equals dy. So continuing this guy over here, we get the integral of 1 over u du, which ends up being ln of x plus c, not ln of x, ln of u plus c, and since u was y plus 5, we have ln of y plus 5 plus c. Gross, 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 gross. Now over here is very friendly. The right side, very friendly. Okay, the integral of x is 1/2 x squared. The integral of 2 is 2x plus some arbitrary c again. Okay, so let's bring all that down, and we're left with this. Now I have to get y all by itself. This is going to be disgusting. So what I can do is, I don't need both of these plus c's, so let's get rid of that plus c on the left. And so that leaves me with ln of y plus 5 equals 1/2 x squared plus 2 plus c. In order to get rid of that ln and isolate the y, I'm going to have to e to the both sides. Now I know that's not proper, but if I e to the both sides, what that does is it allows these to cancel out and it drops down y plus 5. Now the right side is e to this whole thing, 1/2 x squared plus 2 plus c. But wrapping this problem up, we subtract 5 from both sides, and my final answer is going to be y equals e to the 1/2 x squared plus 2 plus c minus 5. Pretty? No. Correct? I hope so, otherwise I'm wasting my time. Find the general solution of the differential equation y prime equals y cos x. Now, I'm going to turn y prime into dy dx. Looks better. Y cos x. I'm going to multiply both sides by dx and divide both sides by y at the same exact time to separate the variables. So if I multiply both sides by dx, the right side becomes cosine x dx. And if I divide y from both sides, I get 1 over y dy. Now what I do is I integrate both sides with respect to their variables. Integrating 1 over y dy is ln of y plus some arbitrary c. Integrating cosine x is going to be regular sine x plus some arbitrary c. Now I only need one of these c's, and so since I want to get y all by itself, let's just get rid of this c on the left side. Don't need it. And in order for me to get y isolated, I need to take the e to the of both sides. What that does is that allows the e and the ln to cancel out, leaving me with just a y down here. And on the right side, I'm end up with e to the sine x plus c. And that's my guy. Find the solution to the differential equation dy dx equals xy squared with the initial condition y of 1 equals 1. Well, let's do this guy first. I'm going to rewrite it. Dy dx is going to equal x squared y squared. So let's multiply both sides and divide both sides by y squared at the same time to get you this. 1 over y squared dy equals x squared dx. Let's rewrite this guy one more time. Y to the negative 2. dy equals x squared dx. Now let's integrate both sides with respect to their letters. Okay, so the integral of y to the negative 2 is going to be negative 1y to the negative 1, so I'll clean that up, plus some arbitrary c equals, let me see, you just become 1/3 x cubed plus some arbitrary c. Now, let's clean this up. I only need one c, so let's get rid of this one. Let's write this out as negative 1 over y equals 1/3 x cubed plus c. Now, in the last section, I would have stopped. Well, no, I wouldn't have stopped right here. I would have solved for y, but I would have almost stopped right here. What I know is we have an initial condition of the point 1, 1, which is an x and a y value. So what I can do is I can find out what c is depending on those points and then go from there. So I have, let me see, negative 1 over my y value, which is 1, is going to equal 1/3 1 cubed plus c. Negative 1 equals 1/3 times 1 plus c. Subtracting 1/3 from both sides gets me negative 4/3 equals c. So putting this all together, okay, I have, let me see, I have negative 1 over y equals 1/3 x cubed minus 4 over 3. Let's make this solved for y, make it better. Since both of these are over 3, what I can do is I can rewrite this guy. And let me do this. Let me rewrite a lot. Negative 1 I'm going to put on the entire top. I'm going to put y on the bottom. Okay, I'm going to rewrite this guy as, let me see, 1 x cubed minus 4 over 3. Let's multiply both sides by y. Or we could just crisscross apples. No, let's multiply both sides by y. Right? Multiply both sides by y. And while I'm at it, divide that entire fraction. So what that will do is that will give us negative 3 over x cubed minus 4. Ugh. I don't like that at all. Not one bit. But that's how you do it. For the differential equation, find the solution that passes through the initial condition y of 0 equals 4. All right, well, I have myself a differential equation, and I'm going to have to find out what the solution equation is to that. So let me multiply both sides by dx and then divide both sides by y to get this. 1 over y dy equals cos x dx. I'm going to integrate both sides like so. That'll get me ln of y dy, nope, no more dy, plus regular c, equals sine x plus c. I don't need that plus c anymore, so let's get rid of it. Okay, let's plug in the point that we have. You're an x value, so you're a y value. Okay, so if I plug in 0, sine of 0 is 0, so I have plus c, and ln of 4 is just ln of 4. Okay, so c is going to be ln of 4. So the equation that I come up with when I take u and put them together is ln of y, right, ln of y equals sine x plus ln of 4. Let's do this. Let's subtract ln of 4 from both sides to get this. Ln of y minus ln of 4 equals sine x. These two combine to make ln of y over 4 equals sine x. If I e to the both sides, that allows y over 4 to drop down, and I have e to the sine x. And if I multiply both sides by 4, I end up with 4e to the sine x. This is going to be b. Isn't that neat? Isn't that something? One of Mr. Thompson's calculus students attempted to solve the differential equation with the initial condition y equals 3 and x equals 0. In which step, if any, does an error first appear? All right, so what did they do first? They decided to divide by y and then multiply both sides by 2x. So far, I don't see any issue. Let me show what I would do. That would make it 1 over y dy equals 2x dx. And then they integrated that. All right, so far, check. U become ln of y, or they like to put the absolute value around it, which is perfectly acceptable, equals, what would that be? X squared, regular x squared plus c. Okay, check. They decided to e both sides. So that's good, check. Since y equals 3 when x equals 0, well, let me cancel that out. So y is going to equal, the absolute value of y is going to equal e to the x squared plus c, so that's going to be y is 3, so 3, the absolute value of 3 is 3, equals e to the 0 squared plus c, so e to the c. Okay, so e to the, oh, they dropped the c down. They get rid of that. Oh, I see what they did there. So that c went from being in the exponent to not being in the exponent anymore. It should still be in the exponent. So that's where the mistake occurred. So step 4 is where the mistake is going to occur. Ah, silly geese. Silly Mr. Thompson student. Find the particular solution y equals f of t for the differential equation dy dt equals 8y with the initial condition y of 0 equals -2. This is one of those guys where we split things into two parts, integrate both sides. So the way I'll handle this is I will simultaneously multiply dt to both sides and divide y from both sides. That'll look like u. Dividing y puts the 1 over y on the left, dy is still on the left, and that's going to equal 8 dt. Now we're going to integrate both sides. Okay? Integrate both sides with respect to y on the left, t on the right. When I do that, I end up with ln of y on the left plus some arbitrary c, and on the right I have 8t plus some arbitrary c. both C's aren't really necessary, so why don't I move that one and just simply get rid of it? Problem solved, problem solved. Now, what I'm going to do is I'm going to, I think I'm going to not solve for y yet. I think I'm going to wait. I'm going to deal with this first. So I'm going to call ut and I'm going to call uy. And so I'm going to plug stuff in. ln of negative 2 is equal to 8 times 0 plus c, thus giving us c equals ln of negative 2. So let's put u and u together to get ln of y equals 8t plus ln of negative 2. Now I know what you're thinking, that ln of negative 2, scary stuff, don't lose sleep over it, trust me on that one. So let's solve for y, and we'll do that by subtracting ln of negative 2 from both sides, like so. Let's move that up here. We've got ln of y minus ln of 2 equals 8t. Okay, when you subtract ln's, you divide the inside, so ln of y over 2 is going to equal 8t. By the way, negative 2, not 2, negative 2, that changes things. All right, when I e both sides like this, or e to the both sides, that cancels out and I'm left with y over negative 2 equals e to the 8t. Multiply both sides by negative 2, and y is going to end up being negative 2e to the 8t. And that's going to be b. Hooray! During a recent outbreak, the number of people infected increases at a rate proportional to the current number of infected individuals. If 400 people are infected when the outbreak is first discovered and 600 people are infected 5 days later, how many people are infected 10 days after the outbreak is first discovered? So we're going to deal with an exponential function, and we're going to do capital I of t for infected. T is going to be in time. Okay, we're going to have our initial value, which is going to be 400, e to the sum k, t for time. What I need to do is find out what that k is. So what I know is that in 5 days we have 600 people infected. So why don't I, quote unquote, plug in 5 for t, so we'll put 5k right there. Okay, 400 is still 400, e is still e, but on the left side that's going to be 600 people. Now let's find out what that k is and do a little bit of math. Let's divide both sides by 400, like that. That's going to give us 1.5. Is going to equal e to the 5k. In order to drop that k down, let's ln both sides. So ln of 1.5, ln of e to the 5k cancels out, drops down to 5k. So I have ln of 1.5 equals 5k. Divide by 5, divide by 5, and k is going to equal ln of 1.5 over 5, which I already looked at ahead of time, is going to be 0.0811. That's what k is. All right, so now that we know that, we can go back to this equation up here and change this equation to 400 e to the 0.0811 t. Now I care about 10 days later. So this is just me throwing stuff into a calculator. 400 e to the 0.0811 times 10 is going to be 900, give or take, which is going to be B. Infections, aren't they the best? Bacteria in a certain culture increase at a rate proportional to the number present. If the number of bacteria doubles in 5 hours, in how many hours will the number of bacteria triple? Well, we're dealing with exponential stuff. So here is a nice exponential equation. We'll do n for number. That's going to equal the initial value times e to the kt. Now, I don't know the initial value. No clue. So I'm going to leave that like that. Okay, but what I do know is that it's going to be 5 years, and it doubles. So whatever n sub 0 is going to be 2 n sub 0. Divide both sides by n sub 0, like that. and 2 is going to equal e to the 5k. Now, in order to solve for k, we're going to ln both sides, and that allows that e to go away and drops the 5k down. So we have ln of 2 equals 5k. Divide by 5, divide by 5, and I looked at this ahead of time. You are going to get a number, but you know what? I'm going to leave it like that. I'm going to leave it like that because they don't want us to change things around, so I'm going to leave it like that. K is ln of 2 over 5. Now that we have that information, we have K, I care about what's going to happen when the bacteria triples. So I'm going to create a very similar equation that I have over here, and I'm going to do 3n sub 0 equals n sub 0 e to the 5 times ln of 2 over 5. And you know what? I want how many hours, so I don't know t. So let's get rid of that 5. Silly me, wasn't thinking there. Let's get rid of that 5 and make you a t like so, and you're going to be over 5. All right, much better. Okay, so what I'm going to do is I'm going to do the same thing. I'm going to divide both sides by n sub 0, divide both sides by n sub 0. That crosses out. 3 is equal to e to the ln of 2 over 5t. If I ln both sides, that crosses out, and I am left with ln of 3 equals ln of 2 divided by 5t. In order to get t all by itself, let's multiply the reciprocal, so multiply both sides by 5 over ln of 2. Multiply this guy by 5 over ln of 2, and you end up with 5 ln of 3 over ln of 2. Wild stuff. Wacky, wild, terrible stuff.